qualitative analysis. Last week, you learned to identify the presence of impurities in substances and to determine the level of purity of that particular substance as well. So today we are going to see how we use qualitative analysis to identify gases like hydrogen gas, oxygen, ammonia, sulfur oxide, chlorine, and water vapor, H2O, also carbon dioxide gas. We are also going to know how to identify cations. I'm sure that my students at home can define what a cation is. A cation is a positively charged ion, and as you know that an ion is a what? Is an electrically charged particle. An ion is an electrically charged ions, that is the positively charged ions we are going to identify are lead ion, Pb2 plus, Al3 plus, that is aluminium ion, Ca2 plus, calcium ion, Zn2 plus, that is zinc ion, Fe2 plus, and Fe3 plus. They are ion 2 and ion 3 ions. Likewise, we are going to know how to identify the presence of Cu2 plus, that is copper ion. Reason. So you carry out the test in the order given. Then the third step, make observations and record them in a suitable format. You make observations and record them in a suitable format. So you write the test, observation, and inference in a tabular form. And the reason you have to make and record the observation immediately is if you do not record them immediately you are carrying out the test, there's possibility for you to forget maybe the solubility to ion that appears blue in color. Is it green? Green is usually ion 2 ion, Fe2 plus. Is it brown? Brown is ion 3, shows the presence of ion 3 ion, Fe3 plus. So you have to state the color also. So now I want you to know this so that it will be very easy for you to know what you are looking for when you are carrying out qualitative analysis on an unknown substance. The color specifically tells us what contains Na plus, that is sodium ion, K plus, potassium ion, or NH4 plus, ammonium ion. Let me say that again. When you are given a particular salt sample or some sub samples in a sample bottles and you discover that they are white in color, is either that salt sample contains the presence of yellowish brown. The salt is likely to contain Fe3 plus, that is ion 3 ion. Ion 3 ion. Fe2 plus appears yellowish brown in color, Fe3 plus. So if it is grayish or metallic, so it shows the presence of metals like zinc, like magnesium, and aluminium. So another observation that you need to take, that is your preliminary observation. Limestone, the one that is used in making cement, CaCO3, it is insoluble in water. Carbonate of magnesium, MgCO3, is insoluble in water. So carbonate of zinc or silver, all these are insoluble in water. It is only the carbonate of potassium, sodium, and ammonium that are soluble in water. So another anion that we want to consider is chlorides. Chlorides, Cl-. Chlorides are soluble in water. Chlorides are soluble in water. All chlorides and lead. Let me to be able to identify any sort, especially when you want to sit for external examination like GCE, whereby you are to write, you sit for an exam that is alternative to practical. You will not be provided with the sorts, or you will not be asked to carry out any practical on any substance. No substance will be given to you, so you have to fill in the space given. So you should know that all nitrates are soluble. It will be very easy for you to write your exam. And of heat, you need to heat the liquid, and when you are doing that, you heat gently. You use a non-luminous flame. We have Bunsen burner with a source of heat like our cylinder in the laboratory. So you heat gently with a test tube. And also, when you want to do this, you move the test tube up and down the flame. You don't just stay stagnant. You don't just put it there until there's a color change. No, you move it up and down so that there'll be what? Thorough mixture, and the reaction will be able to reach completion on time. It will be able to come to an end without wasting time. You move the test tube up and down, and you stop heating as soon as so it depends on the color. It can be a white precipitate, a green, or blue. At times the precipitate can be gelatinous, just like from the word gel. It looks like gel, and like when you make your custard and you add maybe enough water to it, so it can be gelatinous precipitate. Then you record the color, and whether you should record whether that substance is soluble or insoluble after using your reagent like sodium hydroxide, aqueous ammonia, wonderful students listening at home. I have just a few questions for you this morning. If you are there, I have mentioned the colors of these substances before, these sorts before. So I don't know, maybe you will remember. So let me ask, state the color of the following substances. State the color of the following substances. Sodium carbonate. Sodium carbonate. So the line you have to reach us on this morning is 07047 oxide, copper 2 oxide. I've mentioned that color before. They mentioned the color copper 2 oxide. Anyone there? So the number once again is 07047003969. 07047003969. That's the line to reach us this morning on Class on Air. Okay.
Hello, ma.
Yeah, hello, good morning.
Hello. I'm the one calling again.
Oh,
Sorry.
Solia, thank you for calling in. Red litmus paper, it will turn to blue litmus paper. So you know acidic turns blue to red, while basic turns red to blue. So if the color remains unchanged, it shows that the gas is what? Neutral. Like oxygen gas is neutral. It's neither acidic nor basic. So litmus paper can be used to test for the acidity or the basicity of the gas that is evolved during the qualitative analysis. So when you are doing this, you do not allow the litmus paper to touch the solution that you are heating. It is only the flame, it's only the gas that is evolving that you place. An odorless gas is odorless gas. So what's the effect on litmus paper? So oxygen has no effect on litmus paper, either wet, red or blue litmus paper. It does not have any effect. So it means that oxygen is neutral. So the second gas is nitrogen gas. How do we test for nitrogen gas? When you are heating a liquid and the gas is evolving from the test tube, you hold your litmus paper, you observe that the color is colorless, because nitrogen gas is also colorless. It does not have any odor as well. Then effect on litmus paper, no effect. So the gas can either be oxygen or nitrogen. So there's an advanced test that will now differentiate between nitrogen gas and oxygen gas. Next class we will do that. So the next gas we want to test for is carbon dioxide.